So let's do this. So if I need to start doing this kind of research, I'm gonna be really basic and I'm just gonna go straight into Google. Let me just even close other tabs. I'm just gonna make this a little bit bigger and I'm gonna say AAVE. Now let's take a good look at the website. Um, so what they give us as information here is that, well, as a liquidity protocol where you can earn interest, borrow assets, and build applications. And then I think now we're up to 7 billion EVL. And there's also this other markets thing. So was first deployed on Ethereum. I guess we're just talking about different blockchain options you have. Okay. And also have grants. Interesting. So we can see here a bunch of big names over the auditing. So Backshield, Tray of Bits, Sigma Prime. Awesome. And we can see the treasure. They have a DAO, one of the useful ones. Now let's go and head over the fact first. Then I'll go for the docs. Okay. Okay, I'm gonna make myself a little bit bigger because I know it's hard for you guys to follow. Okay, this is the fact. Okay, what is AAVE? AAVE is a decentralized non-custodial liquidity market protocol where users can participate as suppliers or borrowers. Suppliers provide liquidity to the market to earn passive income, while borrowers are able to borrow in a over-collateralized, perpetually, or under-collateralized one-block liquidity faction. So I guess here we're talking about me having to stake the money in there and leave it in there. And here we're talking about flash loans. Did they point out that they had registered there? Yes. So they point out they have a Discord server and why to use AAVE. AAVE has been audited and secured, so I don't want to know the shield part. Um, How do I interact with AAVE? In order to interact with AAVE, you simply supply your preferred asset and amount. After supplying, you will earn passive income based on the market borrowing demand. Additionally, supplying assets allow you to borrow by using your supplied assets as collateral. Any interest you earn by supplying funds helps offset the interest rate you accumulate by borrowing. So the idea here insofar that everybody puts money in the pool and you make your money available to the market. So you're gonna be making fees over other people borrowing, doing flash loans. Quite interesting, to be honest. What is the cost of interacting with AAVE? Interacting with the protocol requires transactions and transaction fees for the Ethereum blockchain usage, which depend on the network status and transaction complexity. Where are my supplied funds stored? Your supply funds are located in a smart contract. The code of the smart contract is public, open source, formally verified, and audited by third-party solution. You can withdraw your funds from the pool on demand or export a tokenized A tokens version of your lender position. A tokens can be moved and traded as any other. So there's a little bit of a important bit of information here, which is you can withdraw your funds from the pool on demand. So first thing, you can take your money as you want, or you can get a token that's equal to your position. So here now we're talking about leveraging yourself to the tits, and quite classical with crypto things. So address screening. Here comes something new. Why is my wallet blocked? We receive a blockchain intelligence provided by TRM Labs. TRM combines on-chain data and real-world investigation to identify financial crimes and other prohibited activities. These data show wallets from APE. These data blocks wallets from APE app. Okay, they are associated with certain, basically KYC wallets. At least that what looks like in here. Not KYC maybe, but yeah, if some hacker can really like block your account just because by sending you like some tokens. Is there any risk? No. Platform can be considered entirely risk-free. Risks related to our platform are the smart contract risk of bug within the protocol code, and the liquidation risk on the collateral liquidation process. Every possible step has been taken to minimize the risk as much as possible. Protocol code is public, open source, and is be audited. Additionally, there's ongoing bug bounty live and running. The entrant is explaining a little bit about how the A token's relation to the pool works. Okay. Okay. AAVE token. AAVE is used in the center of gravity of AAVE protocol governance. AAVE is used to vote and decide the outcome. Yeah, it's true. It's a really bold one to say no risk. But I know that they are really meticulous with the protocol development in there. AAVE is pretty much, I guess like if you're gonna work on places that are respected in crypto, like let's say big companies, I guess it's always good to work to layer one. So it's nice if you like there's few layer ones that is nice if you work in there. I guess Ethereum, if you work on the Ethereum Foundation doing client development, that's fucking cool. If you work on Polkadot, that's cool too. But I guess working at Aave is even cooler than maybe working at these companies. Because they are really like I think maybe number one. I don't know. So pretty much Aave token is governance and can be staked within the protocol safety module to provide security insurance to the protocol suppliers. Stakers can earn rewards and fees. Okay, so mobile app, there's a white paper, and let's see the risk framework. I never saw such thing in my life. And developers have a technical documentation for a technical. So we now kind of know, oh, that's really good. And Aave, how to fix that and become an Aave contributor. Well, let's take a look at the white paper and see if there's any complicated math or is this one of the good. Have you guys ever seen a formal audit before or an audit from Certora? So we can kind of see here how this work. I really wanted to see the white paper. Maybe. While that's happening, let's see if you can see guys. We have the white paper. Cloud 2.0. Here we have the architecture. Let's try to understand. Nice, bro. I'm gonna send you the link so you can. 1 second. Very. So if we look here to the white paper and we take a look on their explanation of the architecture of the protocol, is the really like nice part to get into for us as developers. Um, take a look and try to understand what's happening. A little bit. Okay. Let me just see something. Okay, so everything starts with the user. the user can do such things. He can do flash loans, deposits, he can borrow and repay. Repay is probably when you when you borrowed money and then you can redeem probably staked things, swap. Okay. Now let's go over the least complicated path. So let's say that the user wants to swap. Go into the lending pool. The lending pool is going to the lending pool car, and they do have reserve uh, reserve pools in here. I think maybe it could be a little bit in the same style of Uniswap. Um, okay, so we know the process for swapping. Pretty much they're using the lending pool, and the lending pool is using the lending pool core. Probably this guy. Now what I want to do, and guys, tell me if this is too much. Okay, but what I want to do is take a look at this contract. I want to see lending pool and lending pool core. Okay. Lending pool core. So deployments flash loan MISC protocol problem. Pool, lending pool, lending pool. No, I'm not looking at the collateral manager. I'm not seeing the core. Probably maybe two contracts inside the lending pool. But yeah, just from the start, we can already see API encoder V2. They have modern ABIs. All the stuff is happening here, and I'm looking for the core thing. Probably not in this folder. Let's go back to the lecture. Lending Oracle core library. Lending pool configurator. So the lending pool configurator is the one accessing the core. But let's take a look at the swap function of this contract so we can try to see what's going on. So I have this swap borrow, swap borrow rate. How long? How big is this? Oh, bro, they really put out a 1,000 line contract. These guys. At pause, they have a pause, set a configuration, set the reserve interest rate. It's bigger, right? You guys not being able to just so set the reserve interest rate strategy address. So they have these contracts doing different strategies. Initialize reserves, the tokens, the debit, variable debit, interest rate strategy. Let's look at swap. Validates and finalizes a token transfer. Get user account data. So we are doing that. We're getting this information from like this generic logic. Really, this is the name of the thing. Calculate user account data. Probably some hashing. No, I don't think so. Here we have a flash loan function, very interesting function. Basically, a flash loan is just a function that will give you the money during the scope of execution. Usually, in the end, you're gonna have a check for you actually paid. Obviously, AAVE could have implemented that in a much more elaborated way. I'm not looking at that. I want to kind of see liquidation call. So we do a low level call to the collateral manager. And the interesting thing in here is I wonder if this function is public for everyone. It's just this because liquidation call could be public, right? I could be the one trying to liquidate an account. That really makes sense. Hey, Kulin, welcome, bro. Guy, talk to me. Talk to me in the chat, please. Um, Set user reserve as collateral. So I guess this is when the user wants to borrow against what he deposit. He balanced stable borrow rates. Don't know what that means, but let's look at the swap borrow rate. So we're trying to find this path. Um, so we're passing the address of the asset and the rate mode, which I wonder what is the rate mode. If interest rate mode is equal stable, what we're gonna do is we're gonna burn an amount of stable debit and mint a variable amount based on that. Okay, okay, awesome. And here we have another function for repaying. Awesome. I guess this gives us a little bit of a vision. Okay. Let's try to look at the redeem function. Everybody's always going to, so you can really see that this lending pool acts as a, this adapter contract to the other protocol functions. Let's go back to the lending pool, and now I want to talk about redeeming, and or let's maybe do something that is more intuitive for us. Let's see deposit. Um, deposit, deposit. Here we go. So we take an asset, we take the amount on behalf of, meaning that the owner here is not message sender. Actually, it is message sender, but message sender can make a deposit on the behalf of someone. That's okay. On behalf of someone. There's a referral code. Let's try to understand what the function's doing. First thing, we're reading, we have this data type, and we're reading probably maybe how much reserves we have. And then probably we're validating if this deposit is too big or too small, probably something that's like that. Then we load, based on the reserve for this asset, we load the A token, so the AAVE token, the equivalent AAVE token. We update the state, very interesting. And we do a update in the interest rates because we just got a new deposit and we just issued probably AAVE tokens to represent that. Then we finally do the transfer from the sender a token amount, meaning that this is coming to ERC asset. ERC asset. Okay, so we are pretty much sending the asset to the sender to the Advent token smart contract. And then we check if this is the first deposit based on this AIT token. So we take a look at the A to A to IV token, the equivalent AAVE token for this asset. When we want to execute the mint function, probably this function returns a boolean, and there's a check in there to see like, okay, I already did that, and then it's just returning. But if it's the first deposit, then we're gonna be setting that as collateral for you to use for your borrows. And we even emit an event so we can track everybody, setting the collateral. Really clean, really easy to understand. Deposit function really intuitive to go through. Let's look at the borrow. Since we look at the deposit, now let's look at the borrow. Is this good, guys? Guys are liking this? Take time, put it in. Okay, cool. Let's go. We're going now for the borrow. No, no problem, bro. And you can lurk, no problem. So let's take a look at the borrow function. We pretty much taking the asset, the amount, we're passing the mode, referral code, and on behalf of. We're not pause it and override our things should be seen here in this function. Then pretty much loading the results and calling this function. I wonder if I can actually not really calling the execute borrow function with the structure executed borrow param. So let's go over the execute borrow function and see how that part works. Thank you so much for reading, bro. It's all worth it because you guys are around. Okay, it's really nice for me too. Um, so, bro, let's take a look here. Execute borrow functions. We passing the params, the structure of params. Another thing for you guys to see here is the memory here, the use of memory here. I think that with the new versions of Solidity, we don't need to do that anymore. Um, and then we do what? We load the reserves and we load the configuration map for the user. I wonder. Okay, so this is actually the means for me to load the wallet and other information of the behalf user. I just go over the storage and just read it. Oracle, boom. First thing here, we get the Oracle price. I wonder what Oracle is being used here. I suspect it's not Chainlink. If I'm not mistaken, AAVE has its own Oracle thing. But I could be massively wrong in saying that. So we get the oracle and then we get the amount in each. So pretty much we do a calculation of the price of the asset multiplied by the amount and divided by the decimals, which will give us the price of the asset in ETH. And then we do this validation logic, validation borrow. So we have this contract that will make sure everything here is, valid. And then we're going to update the state. We're going to set the current stable rate to 0. And let me see, because I'm just borrowing that should be set to 0. Interesting. And the first borrowing also got set to false. Okay. So let's go over data types, interest rate mode, vars, interest rate mode equals data types, interest rate mode stable. So if the interest mode is stable, what we're going to do is we're going to create the debt based on the stable debt token. And if it's a variable debt, not stable, so based on some other token, we're gonna be minting the other token, the AAVE tokens based on token 0. Then we update the interest rates because people start borrowing, and then we do a release underlying. So we transfer the underlying token and then we emit the borrow. We clean to really easy to understand. Let's go to now. What I want to see is the flash loan function, and I want to see how the flash loan connects with the data provider to create the repay mechanism. I don't know if you need to repay the flash loan using the repay function. Yeah, no, that comes from the Solidity version for sure. I wonder if I pay the flash loans like with the repay function. Let's take a look at the repay function. or if the repay for if it's for like any kind of debt, and just by looking at the code looks like it because I'm talking about stable debt and variable debt. So I think you're supposed to pay the flash loan in the same function. I mean, not in the same function, but in the same execution. So let's take a look at the flash loan, and I want to see a little bit deeper now. So well, let's see how this works. So first thing, the flash loans, I guess to say gas, you can do it like with several assets for several amounts in different modes, which shows, a little bit of flexibility here, super nice. Then we create the fixed size positions for the arrays we need. Then we go over each one of the assets and transfer the underlying. So here we are already doing the flash loan. Now, this is probably the function you need to implement in your smart contract to execute the flash loan so when the money hits your smart contract, this execute operation probably will be the one making sure you're returning a true, and yeah, I believe that could be the case. And then after that, what we have is we go for each one of the, yeah, let me see. Not working for me, bruh. You know. But yeah, but I'll take a look at that. Yeah. After that, we go over the arrays we created, and we're gonna calculate the amount of premium. So how much you need to pay over what's your flash law. And then we're gonna have to do some cumulative liquidity math here to get the new amounts for the assets, and then update the interest rates. And in the end, we do a safe transfer from the receiver to the address of the token with the premium. So probably your contract will need to give the approval to AAVE to execute the flash loan and then be able to move the money back. And this is the case for the where there's no, take a look. Maybe I need to click on the editing thing, right? And then it will let me navigate. And this is for when you don't have a interest mod rate set. Okay, so if you do have one, the function that we're gonna be executing a borrow. Because you can do a flash loan, not return the funds, but then that will be subtracted from your collateral. Okay, and if you do that, it's pretty much going to be like a borrow, so it's going to counting as a borrow. If the user choose not to return funds, the system checks there's enough collateral and eventually opens the debt position. Yeah, really, really interesting. Wow, and I guess not so hard to understand. So we know that the repay function is not really for that. Okay. Now I want to see the flash loan happening over the chain, and I want to find out what is the name of the function that I must have in my contract to receive that money. And to do that, I'll try what Reentrant is saying with try to edit this file and see if I get some code navigation from it. Then I'm gonna go for flat loan. No, I'm not. I'm not getting the code completion. Yeah, maybe we should do a little bit of a dive into docs. Something. Configuration libraries, landing pool, and landing pool data provider. What is a data provider? It's how we set up the oracles. Let's take a look at that. What is false libraries, landing pool, collateral manager, configuration, storage. And these are probably interfaces. Base, base. So all the flash loans, landing pools need to inherit from this contract. So they can already have default safe math and safe ERC20. Plus you pass in the address of the provider. Let's take a look at these libraries, and I want to see landing pool configurator. How many lines of code? 400 lines of code. Let's take a look at these. Initialize, batch request, init reserves, update token, update stable debit. It's funny because they didn't use to like they do change the implementation, but they didn't went with proxies. Guys, yeah, and the impulse storage. Interesting. They have a smart contract just to handle that. Lending pool collateral manager. This one is really important. Liquidation call. And this brings me back to the question we made before, which is the question of is this function public? And it is, you can see that if anyone can call it. And I guess that's when we talk about the liquidation bots, we're talking about people using this mechanism to liquidate people. I have no idea how this works, but I really want to find out. Whoa, it's a piece of code, eh? Let's take a look. Let's take a read. So we do the collateral reserve and we do the debt reserve. So as soon as you have debt, someone can come and liquidate you. I see. Liquidation call local var. So we create this structure and then we do this generic logic thing. I wonder what that is. Let's see generic logic. Hey everyone, feel free to open your mics and participate. Okay. Calculate user account data. So probably I'm gonna bring everything ready to use. I'm gonna send all this information and receive back health factor. So is this account green or red or yellow? At this point, we load the hey Anom, welcome back, bro. We're going over the AAVE smart contracts. So at this point, we're going over the user stable debt and the variable debt, and we get both informations from the helper. Okay, we pass in the user and the information we have as debt reserved. Then we do a validation over the liquidation call, and it's interesting that Aave really protects their code. Like really have this validation pattern all around. Um, if there's no errors, what we're gonna do is we're gonna load in the equivalent Aave token. We're gonna load in the user collateral balance, and I wonder if user here is the sender or the user being liquidated. Probably the user being liquidated. Um, yes. Then I load and calculate what is the maximal liquidable debt. So I just use what's being done here is we add the variable debt to the debt over another tokens, and then we do a percent multiplication based on the liquidation close factor, and these could be tied to leverage. So I guess if you're leveraged, this is where you're gonna get a little bit of a you could have problems and become less healthy. You know, if you have more leverage going on. And then we're getting over the actual debt to liquidate. So we have debt to cover. So debt to cover, if debt to cover is bigger than max liquidable debt, means that we're gonna be using the max liquidable debt. So because yeah, because we're gonna liquidate as much as we have, you know. And then otherwise, if it's not, we're just gonna use the depth to cover for everything. From that we okay, so we do this if here, and then we do this operation to load the max collateral to liquidate and the debt amount needed. We pass in the reserves, the assets, and the user collateral balance. If the actual debt to liquidate is bigger the debt amount needed, I'm just gonna take what you sent at this point and use it to liquidate. So we're just gonna overwrite the actual debt with whatever value you sent. Um, if the liquidator reclaims the underlying asset, we make sure there is enough available liquidity in the collateral reserves. How do we do that? Okay, so if there's no received token, meaning that the liquidator reclaimed the underlying asset, we're going to calculate the available collateral based ourselves on the collateral asset and the balance of the token, the Aven token smart contract. Okay, so we're going to see how many tokens we have in there. If the maximum collateral that I need to liquidate is bigger than whatever I have right now in the smart contract, then we're gonna have an error saying that hey, there's not enough liquidity, I cannot repay that. Um, and just so we can remember, we're talking about liquidation calls. Okay. Now, after we do this operation, we go and update the state. And then we have another if here that says that if the user variable debt, meaning that his debt in tokens is bigger or equals his actual debt to liquidate, I'm simply gonna burn the debt token. So the user is calling the liquidation. So I'm gonna burn all the debit from the user. There's a variable borrow index here. No idea what that does, but otherwise, if um, the variable debt of the user is not bigger than what he has to liquidate, we're gonna go over the else here and we're gonna say, hey, okay, but it's bigger than zero, yes. So burn whatever the user has at this point. both in variable depth token and also in stable token. I wonder why would I why why would the total collateral side I got it. So what we're doing in here is okay, so I only want to use your tokens that you I only want to liquidate whatever you have with tokens. But if what you have with tokens is not enough, I'm also gonna liquidate you by your stable coins. So we're going over both situations in here. And because what we're saying is, okay, so there's no token, so I'm not doing this. I'm going straight to your stables and bye bye. In worst case scenario, you have both, you lose both. And once again, it's just a subtract, it's just a burn in an amount, so you still have the debt, the rest of the debt in there. So it's not really, yeah, awesome. Awesome, we got it. And then we're doing update interest rates. We're passing the debt asset, the token assets, and the actual amount to liquidate. I guess here we are persisting all the changes made in here. Now, going back to a situation that we saw here. If the user returns the underlying asset, what we're gonna do is we're gonna get the liquidated token previous balance. This is happening before we transfer back the underlying assets. And then we do a transfer on liquidation, which I imagine is doing a transfer from the user of to the liquidator of AAVE tokens. Okay. Now, if the liquidator didn't have any tokens before, what we're gonna do is we're gonna create a new storage variable for his configuration. And then we're gonna set using as collateral liquidation configuration. So we're gonna set the liquidator configuration to where's these collateral reserves are coming from. Probably we're setting that, so we're using the current underlying asset as collateral in my liquidator configuration. So we're just setting that okay, this user is using this asset, okay? And then we pump out an event preserved used as collateral enable. So I guess the user liquidated someone, gave the tokens back to AAVE, and automatically took AAVE, put that as reserves. And in the case that that will never happen before, we're gonna also, so besides transferring the tokens, we're also creating the configuration part. The only question that I have here is, can a liquidator have more than one type? Or what makes sense for me is having more than one liquidator, Um, okay, so if that's not the case, if the user is not giving back the tokens, we're gonna update the state. We're gonna update the interest rates because there's not as many tokens as before anymore. And then we're gonna burn the equivalent of AAVE tokens because these tokens never came back to AAVE. So we need to burn whatever was in the smart contract so there's no imbalance in the reserves. And here what we do is we look if to see if the max collateral to be liquidated is equal the user collateral balance. If that's the case, we're gonna use this we're gonna use this asset as his collateral on the configuration. So the user configuration will be set to this asset. Actually, no, we're setting this to false, meaning that, okay, the user is now paying this. If he had any debt before, he's now paying, so I can set the configuration to false because he could be liquidating something else after. And then there's a transfer from that happens from the liquidator to token address, the token reserves of the actual debt to liquidate. And in the end, we're setting a liquidation call. Beautiful function. Quite an adventure to go over it, isn't it? I'm gonna stop this session because we have already 1.5 hours, but we can keep on